Welcome to Simplicity and Fun, Learning with CircuitPython. Thank you for attending today. I'm Kattni, and today I'll be sharing with you a topic that's close to my heart. First, I want to say thank you to everyone with PyOhio. You are appreciated, and thank you for making this possible. This talk will discuss how an embedded Python-based programming language designed for beginners lends itself to education. I'll provide some basic information about CircuitPython, why it should work well for education, and then get into the results of my discussions with educators already using CircuitPython in their classrooms. Let's get started. CircuitPython is a version of Python that is designed to run on tiny computers called microcontrollers. There are endless form factors for microcontrollers. This round one is called Circuit Playground Bluefruit. It has a ton of sensors, inputs, LEDs, and more built right in, which means it's a great board for beginners because you can learn to work with each of these things without needing to understand circuits and wiring concepts. However, it is also extensible to external sensors and so on, so you can use it to learn the electronics side of things as well. This and its predecessor, the Circuit Playground Express, are commonly used in education settings for this exact reason. CircuitPython is entirely open source. You can clone it, modify it, contribute your modifications, or use your modified version on your own, everything that comes with open source code. It's essentially Python compatible. The basics and control flow are all the same. For example, your imports, while loops, and if-else blocks are all the same. The further into it you get, you'll find a subset of Python features available in CircuitPython. So you can't always take your Python code and expect it to work in CircuitPython without some changes. However, if you know Python, it will be that much easier for you to step into CircuitPython. CircuitPython was developed from the start with beginners in mind. We wanted to create a situation where someone entirely new to programming and electronics could pick up a microcontroller, quickly get CircuitPython loaded, and immediately be editing and running code. We have focused on the first 5 minutes, which refers to the initial user experience with a project or product. In CircuitPython, the first 5 minutes is the process from picking up a microcontroller board to seeing the results of the first piece of code. In most cases, a new user can go from 0 to blinking an LED in that time. When I went through this as a user entirely new to both programming and electronics in 2017, it took a bit longer than that. But since then, we've continued to refine the new user experience. In an education setting, this means you can hand a student a microcontroller board and have them up and running incredibly quickly, leaving more time for teaching, exploring, and learning. CircuitPython is already used in classrooms and has been for at least a few years. For this talk, I was lucky enough to have some lengthy and helpful discussions with educators who are teaching or have taught CircuitPython as part of their curriculum. I want to discuss their backgrounds and a bit about those they taught to give some idea of the range of folks who chose to teach it. The previous teaching experience ranged from computer science, to classical music and philosophy, to 20 years of business managerial courses. Before CircuitPython was introduced to the curriculum, those that were previously teaching electronics and/or programming began with the microbit and make code or MicroPython, as well as CPython. The teaching environments include computer science classes, workshops, a series of online coding classes, and a university class titled Physical Computing Interactive Art. Students ranged from young children to adults and included students in primary education, undergraduates, graduates, and teachers. 2 educators taught themselves CircuitPython in order to teach it. One had a background that helped with this, and the other essentially started from scratch. The point was made that having a background in it made it easier to learn, but also meant that sorting out how to help students who struggled was more difficult than it would be if they had also struggled to learn it. And learning did not end with the initial effort for the purpose of teaching. Each educator discussed how teaching CircuitPython has continued to be a learning experience for them. The codebase and documented projects provide huge opportunities for continuing education. I asked each educator what their experience teaching CircuitPython had been. There were a wide variety of answers, but they included several common threads. The overall experience teaching CircuitPython is positive across the board. It has been a gratifying experience for students and teachers alike. It is fun to teach and rewarding to watch how engaged students become with their projects. The switch from previous content to CircuitPython came out of a number of similar reasons. First and foremost, CircuitPython is simple to use. Second, it's Python, and in some cases, educators and students were already familiar with Python. And third, the opportunity to teach Python with tangible results, real-world physical manipulation, such as rainbow LEDs, versus teaching Python with data analysis, made a world of difference to student interest and involvement. One caveat to be aware of is that teaching CircuitPython requires the associated hardware. Not all educators have access to a budget big enough to accommodate this. Adafruit offers education discounts, but that may not be enough to fit within a given budget. CircuitPython comes with a solid ecosystem. This includes the Adafruit Learn system, the Adafruit forums, GitHub, a vast amount of detailed documentation, and the CircuitPython community. Adafruit Learn system is home to a wide variety of project guides, as well as product guides being available for most of the products that Adafruit sells. It's a great place for students to go to get ideas for projects that they might want to do. The Adafruit forums provide support from official Adafruit folks. GitHub is where we host all of our CircuitPython core and library code. This makes it simple to track our development and accept contributions from community members. The CircuitPython core and every CircuitPython library has API documentation available. The docs are rendered from within the code, which makes it easier to keep them updated, and they are hosted on Read the Docs. The CircuitPython community is vast, with folks showing and sharing projects, asking questions, and helping others through all sorts of mediums. The Adafruit Discord server is an important part of that. With so many options, it's possible to arm students with enough knowledge to leverage these online resources. Teach them how to find the right information for the hardware and software that they're using. The CircuitPython community is primarily on the Adafruit Discord server. The community strives to be welcoming, positive, supportive, and inclusive. We display our code of conduct prominently, and the moderation team and the community itself work hard to enforce the guidelines within it. The overall result is a safe space for anyone to ask questions, assist others, and share projects. Many of the folks on Discord who are helping others are members of the community who volunteer their time. The Help with CircuitPython channel is available for folks seeking assistance with using CircuitPython. The CircuitPython-dev channel is available for development discussion. We say code plus community equals CircuitPython, and we mean it. We could write code all day long, but without community involvement, CircuitPython would not be the amazing thing it has become. Educators have provided information on the community to students as a resource to be used while learning CircuitPython. The positive experiences students have with the community helps not only build knowledge, but more importantly, helps build confidence. CircuitPython makes it easy to keep students engaged for multiple reasons. CircuitPython provides the right amount of difficulty to keep students interested. If something is too easy, they don't accomplish anything, and if it's too difficult, they give up. Sometimes finding the right level for each student can be difficult. Some students take to it immediately, others struggle to learn. It's important to curate the content to each student's level, to keep them involved and build their confidence. The tangible result of working with CircuitPython makes keeping students engaged much easier than with something less interesting. Multiple educators said the difference in reaction to manipulating data versus making LEDs light up was significant. There are also many options with CircuitPython, which means students can easily tailor projects to something that interests them. The typical hardware used to teach CircuitPython to beginners is also quite simple to embed in wearable projects, such as the Circuit Playground Bluefruit mentioned in the beginning. This appeals to a very different group of students as it opens up an entirely different avenue for creativity, while still learning programming and electronics. CircuitPython creates an environment where teaching students other important skills goes hand in hand. Not all students are going to continue on to computer science. The process of learning CircuitPython involves things like problem solving, troubleshooting, patience, creativity, research, and much more. These durable skills are valuable regardless of the university and career path a student ends up taking. My hope is that my talk, and the educator experiences discussed within it, have inspired you to consider using CircuitPython in your next electronics and programming class or workshop. Even if you've never tried it yourself, the experience I'm suggesting you provide to your students is the same experience you should enjoy while learning it before teaching it. These are links to some of the resources I mentioned during my talk. My slides and all of these links can be found on GitHub at the first link on this slide. github.com/Kattni/PyOhio2022. Thank you again for attending, and I hope you enjoy the rest of your PyOhio.